Good afternoon, guys. This is Professor David J. De Los Reyes. I got a new topic this morning. This will now be still a variable separable problem, but it is with the so-called y double prime. So you know what is the meaning of the so-called y double prime. Okay, let's proceed. My topic this afternoon on my channel under the course differential equation, still on the first order, variable separable, they should be problem number 4. Another example problem. I've given you already the fourth problem, so this will be the fourth problem under variable separable. It's another problem. So this is actually lecture on the differential equation DE06. We are running smooth and we are running hot. Okay, I will try to read the problem. We are given y prime. It's just like an apostrophe, but in calculus or differential equation, we read it as prime. Y prime. Y prime is equal to 1/2 sine of 3t. The total angle is 3t. Okay. The given initial condition is time is equal to pi when y is equal to -1. So actually, supposed to be we are solving the problem y as a function of t. For the meantime, it is not x. It is with respect to time. So maybe this relates to a distance with respect to time. It could be still, maybe again, a fact of a missile that's flying upward. We don't know. Okay, let's bring out the solution. We are supposed to bring out the particular solution. Okay, let's proceed. dy over dt is equal to y prime. It is read as y prime. Y with a mark like this on top is actually read as y prime. Okay? And under differential equation or differential calculus, that is actually the first derivative of y with respect to time. Y with respect to time? Because the right hand side, the variable on the right hand side is t. So the derivative with respect to time of y is actually y prime. So even though this is y prime, okay, that is actually dy over dt. Or this is actually the first derivative with respect to time of y. You got it? So I think this is the first time that I introduce y prime to be the first derivative. So replacing y prime by dy dt equal to 1/2 sine of 3t. Okay, then we try to separate the variables by multiplying all the terms by dt. This cancels. Left hand side will be dy equal to 1/2 sine of 3t dt. We already have separated the variables. T and dt, this is pure dy. Okay? Because we are to solve y as a function of t, as a particular solution. Okay, I will erase this one so it will look nice, you know. Okay? Integrating both sides. Integrate. The integral, the differential of y equal to 1/2 is constant, so we bring it out, 1/2. The integral of sine of 3t dt. We are now on the operation integration. It's always like that under variable separable. After the separation, we will integrate. So whatever come out for the integration, apply your knowledge of integral calculus. What kind of integration will be? We'll just pray it will be an easy one. Okay. The integral of the differential of y is actually y equal to 1/2. The integral of sine of 3 dt dt. The right hand side is actually similar to the form if you recall our integral calculus, okay, it will be of the form the integral of sine of u du. And the integral of that is negative cosine of u. But let's try to verify the value of u. The value of u is actually the total angle. Okay? U is 3t. Du will be constant, a function, so it should be 3 times differential time. It is not exact. Because on the resulting right hand side, we lack the value 3. Okay? So we will place 3 here, then place 1/3 outside. So y now will be equal to 1/2 times 1/3 is 1 times 1 is 1, 2 times 3 is 6, so this is 1/6. The integral of sine, I will just follow this, negative cosine of 3t plus k. This negative. So y now will be equal to, this negative here refers to the overall sine of the first term, so this should be negative 1/6 cosine of 3t plus k. It is the general solution. So to bring out the particular solution, apply the initial conditions. It's always the same. When t is pi, y is equal to negative 1. Okay, let's try to imagine what is 3 pi. Why 3 pi? Because later on, we will substitute the value of t to be equal to pi. So what comes out on the total angle will be 3 pi, right? 3 pi. 2 pi is actually 360. 3 pi is actually up to here. That is plus 180. Because actually 2 pi is 360, therefore pi will be 180. 2 pi plus pi will be 540. Okay, 540. So 360 plus 180 is 540. So actually 3 pi is actually 540 degrees or equal to 180 degrees measured counterclockwise. So okay, so y now will be equal to, I just compute that one, so we could imagine where will be the location of 3 pi, okay? Y now will be equal to negative 1/6 cosine of 3t plus k. Negative 1 equal to negative 1/6 cosine of 3 pi plus k. Negative 1 equal to negative 1/6 cosine of 3 pi or pi are the same, right? Because 2 pi is one complete revolution plus another pi that is 180 or cosine of pi. And the cosine of 180 is actually negative 1. If you try to use your calculator, 180, but don't worry guys, I memorized this one. 180 degrees cosine, it's negative 1, right? So this what will come out is negative 1 equal to negative 1/6 times the cosine of 180 is actually negative 1 plus k. Negative, negative, this will be positive. So if we try to solve for k, we transpose this one to the left. So k now will be negative 1 minus 1/6. Because minus minus is plus, then we transpose it will be negative 1/6. Okay, what will come out? Negative 1 is actually negative 6/6 minus 1/6. Minus 6 minus 1 is minus 7 all over the common denominator 6. So the value of k is actually negative 7/6. So the final answer, if we try to go back here, y now will be equal to negative 1/6 cosine of 3t plus the computed value of k. It is negative. This is actually plus open quantity negative 7/6. Plus minus, this will become minus. Right? So our final particular solution will be y equal to negative 1/6 cosine of 3t negative 7/6. Particular solution. Okay? How about the graph of this one, guys? It's easy. Try to compute, place the value of t, then try to compute for the value of y. Many 6 points maybe. Then try to plot the graph one by one, then try to figure out what will be the outcome. I will not give you that one. You could do it at home. take the graph of this, assume a value of t start with 0, take one complete revolution, then solve for y. 6 points, then actually you could figure out what will be the figure of this one. It is just like on the polar equations under integral calculus. Okay, guys, that's the importance. What's the importance of this one now? The importance of this one is that we know that the derivative with respect to time of y is actually y prime. So don't be afraid with y prime. First order. Okay, that's why our topic is first order. If this is double prime, that is actually second order already. Meaning our variables are differentiated already twice. But if this is only one, okay, this is one, this is actually first order. Okay? Good afternoon, Los Angeles.